Good morning. Open your toolkit to page 57. Try this question, which is from section lesson 934 warm-up. When you're done, come back and watch the remaining part of the warm-up. You want to find the equation of the line tangent to the graph of this equation, which is 1 over 3 over x, 1 over 3x, at the point -2, comma, -116. So so I tried to sketch a graph of 1 over 3x. And with this graph, you want to find if there is a tangent line that's attaching to that graph at -2, you want to find the equation of that tangent line. To write an equation of a tangent line, two things you need, which is a point. And other than the point, you need also the slope of that tangent line. You have already a point, which is -2 and -1 over 6, but you need still the slope. The slope will be, you can get that slope from finding the A rock and then the I rock from -2 to -2 plus h. So you want to find the A rock and the I rock from -2 to -2 plus h. So I'll start with my information by trying to find the -2, f of -2, which is 1 over 3 times -2, which is equal to 1 over -6. It's already there in my point, but also I want to find the f of -2 plus h. And that's equal to 1 over 3 times the -2 plus h. Now from there, I can get to my A rock. So my A rock is equal to f of -2 plus h minus the f of -2, all divided by -2 plus h minus -2. Now I'll put the information into my equation. The f of -2 plus h is 1 over 3 times -2 plus h minus f of -2, which is 1 over -6. And it's all over -2 plus h plus the 2. Simplifying further, your A rock is equal to 1 over 3 times -2 plus h. The negative times this negative will turn it out to be a positive, so it will be 1 over 6. And it's all divided by -2, and 2 cancel out from the denominator, leaving us with just an h. Now, if I have to think about if I can do the I rock at this point, you're putting the I rock, you're trying to find the limit as h is approaching 0. If you look at this equation, dividing by a 0 will not be acceptable. So you need to work on this equation. It's not an equation that you can factor, but all I can do at this point with this equation is try to add the 2 fractions on the top. So before I even proceed, I want to highlight that this is my numerator and this is my denominator. So I just want you to make sure that you know which one is which when we're going along the way. Going back, I'll add those two. So like Miss Seitz class talk about as cha-cha-cha, and we do it as ovals in our class, in my classes. So I'll do my first oval, which is 6, plus my second oval, which is 1 times the 3 times -2 plus h. And it's all divided by the 2 things in the bottom, denominators multiplied together. So it will be 6 times 3 times -2 plus h. Just be careful with your calculations. And it's all divided by that new denominator, which is h. So again, this is your denominator. And still, this whole thing is your numerator. So I just want you to make sure that you're thinking about which one is your numerator and which one is your denominator. I'll try to simplify what's going on the top in the denominator, in the numerator, and then I'll try to put the denominator. So the denominator is still an h. The numerator, I have a fraction that's embedded into another fraction. So I see 6. Doing the distribution of the 3 times the -2 plus h, it would be -6 plus 3h. And it's all divided by 18 times -2 plus h. Now, still, you can see that this whole thing is your numerator, and this one is your denominator. Now, going back to this question, and I want to simplify even further, you see a fraction that's embedded into a fraction, which is like, it's too much for us to simplify. So maybe if I multiply by 18 times negative 2 plus h in the numerator and the denominator to cancel the fraction that's embedded into the other fraction. In the numerator, I have a fraction that's 3h because the 6 and the negative 6 cancel each other out. And I have here 18 times negative 2 plus h. And it's all still divided by h. And you see a fraction that's embedded into another fraction. So I'll multiply by 18 times negative 2 plus h to your numerator and the same thing to your denominator. So 18 times negative 2 plus h. Now, simplifying further, the 18 times the negative 2 plus h will cancel away with the negative 18 times negative 2 plus h, leaving us with the numerator with 3h. The denominator will be 18 times h times the negative 2 plus h. Now, simplifying even further, I see the h can cancel away with the h. So, and the 3 and the 18, each one of them are divisible by 3. So this would be a 1, this would be a 6. So you will have 1 over 6 times the negative 2 plus h. Now we can definitely do the IROC. And your IROC will equal to the limit as h is approaching 0 for this equation from your AROC, which is 6 times the negative 2 plus h. If I put an h in this equation, it would be 1 over 6 times negative 2 plus the 0. Simplifies to 1 over 6 times the negative 2, simplifies to negative 1 over the 12. For this tangent line, now you have a point which is negative 2 and negative 1 over 6. But also you have the slope at this point after doing your AROC and the IROC, which is negative 1 over 12. Now I can use my equation y minus the y1 equal to m times x minus x1 in order for you to write the equation of the tangent line, the slope of that tangent line. So y minus your y1 is equal to negative 1 over 6, m is equal to negative 1 over 12, and x minus x1, which is negative 2. I want to clear all of those negative signs. So y plus 1 over 6 equal to negative 1 over 12, and I'll keep it in the point slope form, so x plus 2. So you can keep it in this form, or you can say y is equal to negative 1 over 12 times x plus 2 minus the 1/6. Both of them are an acceptable answer. We'll cover section 934 today, and the section is, like the title of the section is talking about how do I find the slope at a point. Eventually, you've been finding the slope of a point forever from section 911, but what's adding to this, what's adding to what you have learned so far? The word, the derivative. So this is the word that we're going to be talking about today, and we're going to be reinforcing. The derivative, like if you talk to any of your calc folks, they will tell you always the derivative integral. Like they will be talking about always the derivative. So eventually, what you've been doing this whole chapter is you were trying to find the derivative at a specific point. So this is not a new thing. I'm not going to be teaching today a new thing. It's just like a kind of like an extent of what you have been taught. So the derivative, which is f prime of x, it's the same as the slope of the tangent of line, which is the same as the instantaneous rate of change. So all of them are the same. So this is just like a new extension to what you have been learning. Look at this one. So I want to go over the math notes before I even get you to your toolkit. The math notes, the definition of the derivative. For any function f of x, we denote the derivative by f prime of x. So this is how you call it. And here you see the derivative is eventually calculated with the IROC, which is what you've been doing since section, I would say 921. And it's calculated as the limit as h is approaching 0 for f of x plus h minus f of x over h. So again, this is just a small extension of what you have been learning. Now, what I would like you to do is try to open your toolkit. Your toolkit will be on page 50. And let's discuss this one, and you can write it down. So again, it's written or read as f prime of x, or first derivative, And again, the calculation is the same as what you have been doing forever at this point. And this is eventually the slope of the tangent line or the instantaneous rate of change. Or if you're talking about an application problem, then it would be the velocity at x. So think about it. It could be the slope of the tangent line. It's the like how do you interpret that? Or it could be the instantaneous rate of change. Or if you're looking at a work problem, the derivative will allow you to get you the velocity equation at any time. Please pause me at this point, copy this one in your toolkit, and let's get back again when you're done. If I were in class, you would have done 136 independently in your groups to 138, and you would have checked the answers along the way. So I would recommend that you pause this video, try 136 all the way to 138, and then come back when you're done to check your answers. And just like make sure that you're on the right track. So 136A, I'll go over 136A, but definitely pause me at this point and try to do your work on your own. 136, you want to find the derivative of at 9. So I'll do, my work will be for A. I want to do f of 9. And then also I want to figure out what's f of 9 plus h, because I want to come closer and closer to that 9. With this one, square root of 9, I'll plug it into my original equation, which is f of x, which is square root of x. So square root of 9 is equal to 3. Square root, plugging the 9 plus h instead of the x, will be a square root of 9 plus h. Now I'm ready to do my AROC and my IROC. So my AROC is equal to f of 9 plus h minus f of 9, all divided by 9 plus h minus the 9. F of 9 plus h, we already found that, which was square root of 9 plus h minus 3 over the 9 and the negative 9 cancel out, leaving us with just an h. Eventually, knowing right away, if I start doing my IROC, I'll hit a big wall because I cannot divide by a 0. So I need to rationalize my numerator, not my denominator, by multiplying by square root of 9 plus h, but with an opposite sign, plus 3 over square root of 9 plus h plus the 3. Now simplifying further, I need to simplify further. So it would be, again, those are two binomials. Thinking about it, those are two binomials with just opposite signs. So it's a difference between two perfect squares. The middle terms cancels out because they will have the same sign. They will have the same term, but different signs. But the first, I'll multiply the first number by the first term by the first term, and the last term by the last term. And the middle terms, you should know that they will cancel each other out. Square root of 9 plus h times the square root of 9 plus h is a 9 plus h. And negative 3 times positive 3 is negative 9. And it's all divided by h times this whole big chunk, which is square root of 9 plus h plus the 3. Simplifying further, the 9 and the negative 9 cancel out, leaving us with h over h times the square root of 9 plus h plus the 3. Simplifies further, again, the h divided by h is 1, so you have over 1 over square root of 9 plus h plus 3. Now I'm ready to do my IROC. So your IROC will equal to the limit as h is approaching 0 for this value that you have from your AROC, which is square root of 9 plus h plus the 3. Simplifying further, if I put an h into the 0 in this equation, it would be 1 over 9 plus 0 is a 9. So it would be square root of 9 plus the 3. Simplifying further, 1 over square root of 9 is a 3 plus the 3. So it's 1 over 6. So f prime of 9 is equal to 1 over 6. For B, you're trying to find the g prime of 3. And you want to do, again, the g of 3 and the g of 3 plus h. So you're coming closer and closer to that 3. So 3 squared plus the 4, which is 9 plus 4 is 13. G of 3 plus h is equal to, I'll be putting the 3 plus h instead of the h, instead of the x. So it would be 3 plus h to the power of 2 plus the 4. Simplifying further, it would be 9 plus the 6h plus h squared plus the 4. Simplifying further, it would be h squared plus 6h plus 13. Now I have all of the information needed to do my AROC, so my AROC is equal to g of 3 plus h minus g of 3 all divided by 3 plus h minus the 3. And g of 3 plus h is, we just found this one in the top, h squared plus 6h plus the 13 minus g of 3, which is 13, all over h. Simplifying there further, the h's, the 13 and the negative 13 cancel out, leaving us with just an h squared plus 6h over h. Simplifying further, each one of the terms in the numerator has an h, so h squared divided by an h is an h, plus 6h divided by h is just a 6. So your IROC is equal to, which is the f prime of, no, actually it's a g prime of 3, which is equal to the limit as h is approaching 0 for the function that you just received, which is equal to 0 plus 6 is equal to 6. So your derivative of 3 for this function is equal to 6. Now for C, h of x is equal to 1 over x, and you want to find the derivative at 10. So you will do h of 10 and h of 10 plus h, so 1 over 10. And h of 10 plus h is equal to 1 over 10 plus h. And you want to find your AROC and your IROC. So your AROC is equal to h of 10 plus h minus h of 10, all divided by 10 plus h minus the 10. Simplifying further, the h of 10 plus h, we just found this one, it was 1 over 10 plus h minus h of 10 is 1 over 10, divided by, those cancel out, leaving us with just an h in the denominator. Simplifying further, I know I can vision right away, if I do my IROC, I'll be dividing by 0, so I know that I need to work more on this equation, so I'll add the 2 fraction in my numerator. My first oval is 10. Your second oval, which is this one at this point, is negative 10 plus h. And it's all over 10 times the 10 plus h. Divided by h. Again, this whole thing is your numerator, the 10 minus the 10 plus h. Divided by 10 times 10 plus h is your whole numerator. Simplifying further for your AROC, you will have a fraction at the top of the numerator in your numerator, which is 10 minus 10 minus h, divided by 10 times 10 plus h over h. Simplifying further that, those 10s cancel out, leaving us with an h over 10 times the 10 plus h, and it's all divided by h. Now think about it. You have a fraction that's embedded into another fraction, so you need to get rid of that fraction that's embedded into another fraction. So multiplying by 10 times 10 plus h in the numerator and also in the denominator. Because eventually this whole thing divided by this, the 10 times 10 plus h divided by 10 times 10 plus h is really 1. Now going further, those 2 cancel out, leaving us with h in the numerator, and for the denominator it would be h times 10 plus h. Now the h and the h from the top and the bottom, the numerator and the denominator cancel each other out, leaving us with just 1 over 10 times the 10 plus h. Now I believe I'm ready to do my IROC. And your IROC will equal to the limit as h is approaching. So your IROC is equal limit as h is approaching 0 for 1 over 10 times 10 plus h. Replacing the h by a 0 or substituting the h by a 0. So it will be 10 times your 10, which is 1 over 100. And ta-da, we completed that question. For question 137, I'll be putting down in the couple of seconds, I'll be putting down the answers. I would like you to make sure that you're doing this question before you come and check your answers. Now here is the work in details about this question. So I did g of 3, which is 6, g of 3 plus h, which is h squared plus 5h plus 6. I did my AROC and I ended up having h plus 5. I did my IROC and I get like 5. So the IROC is the same as the derivative of g at 3, which is equal to 5. I'm hoping that you have get the same answer like mine. And now it's time for us to move to the last question, which is 138. But we have after that kind of an exit ticket. So just stay with me. We'll move on to the question 138, question 138, and you want to find the derivative of g at pi over 4. So the same dilemma with trying to do your AROC and your IROC. And with that, you have g of 3, g of pi over 4. It's equal tangent pi over 4, and I'm hoping that you still remember your trick. The tangent pi over 4, it's in the middle here in your unit circle. With this one, the coordinate point is square root of 2 over 2 and square root of 2 over 2. The pi over 4 has a coordinate point of square root of 2 over 2, comma square root of 2 over 2. Think about it, if it's both of them are the same and you're trying to do the tangent is sine over cosine. They have the same value, so that's equal to 1. Just easier, right? And then g of pi over 4 plus the h, which is equal tangent of pi over 4 plus h. I cannot do anything with this expression. I cannot simplify it further. So I believe I'm ready to do my AROC. And your AROC is equal g of pi over 4 plus the h minus the g of pi over 4. And it's all divided by pi over 4 plus the h minus pi over 4. Simplifying further, the g of pi over 4 plus the h is equal to just tangent of pi over 4 plus the h minus the g of pi over 4 is 1. We get that from the denominator. Those cancel out again, leaving us with just an h. Now I know I can envision if I put an h in, like if I put a 0 in this equation to find my IROC, I will end up with dividing by 0, which is unacceptable. So your only option is to simplify. Eventually, I cannot simplify this one. So your only option at this point is to try to put this equation into your graphing calculator, put it in your y equal. So you put your equation into your y equal equation. Make sure that you change your table set. So you go to second window, change it to ask instead of auto. So your independent should be on ask. If you go to your table at this point, you will be allowed to put the values for x. So try to come, they're saying to try to come nearest and nearest to 0.001. If I put this equation close and close to 0.001, it would be approximately 2. So again, you're putting this equation into your y equal. And then after you put in your y equal, change your, go to second window. So you're changing your table set to ask instead of auto. So your independent should be on ask. And then go to your table and try to plug in the 0.001. You should get approximately 2. So the derivative of g prime of pi over 4, it's equal to approximately 2. So this is the type of question that you will, there's no algebra you can do to figure out this problem. So your only option will be to figure out that problem by using your graphing calculator. With this problem, it's very critical, which is kind of an exit ticket if we're in class. It's very critical that you work on this problem on your own. When you're done, come back and check your work. I would like to walk you quickly over what I've done with the first part when I'm trying to find my AROC. I found, first of all, f of x, which is the same equation because you're just replacing the x into the x. The f of x plus h will be replaced, the x plus h will be replaced into your x. So to be 2 square root of x plus h minus 3. I started my journey of trying to find my AROC, which is the f of x plus h minus the f of x, all divided by x plus h minus x. Simplifying, I ended up seeing from this step with this, which is this step here, I ended up seeing, like, I know that I'm not going to be able to have an h in my denominator because I'm trying to find my IROC and I cannot divide by a 0. So I rationalized my numerator by multiplying by this expression, but instead of the negative, positive in both the numerator and the denominator. And I still continue the journey of simplifying further. Recall when you're trying to multiply this binomial here by this binomial, you're trying to, there are difference between two perfect squares, so the middle term cancel out, and you're just multiplying your first term by the first term and the last term by the last term. Simplifying further along the way, it's 2 over square root of x plus h plus 2 square root of x. So just make sure that you're going along the steps when you're looking at this question. So your a rock is equal to 2 over square root of x plus h plus 2 square root of x. Now I'm ready to do my I rock, which is the same as the derivative of x, because it's not at a specific point, it's at any point, which is equal to the limit as h is approaching 0 for this big chunk of my denominator. Putting the 0 in this equation for the h, so to be square root of x plus 2 square root of x. Now those two in the denominator are like terms, so it will be 3 square root of x. So your derivative or your I rock at any value of x is equal to 2 over 3 square root of x.